Can you hear me now? Okay. All right, got that fixed. Okay, so like I said, we want to continue talking about probability. And there's two main words that we need to make sure that we all agree on how they're going to be used when we're talking about probability. And those are the words or and and. And we're going to use these words to combine events to make new events. So, quick reminder, let's consider the situation where I have a six-sided die. We've previously said that the sample space for rolling a six-sided die is 1, 2, 3, 4, 5, or 6, and that those events are equally likely. We said that each one of those individual outcomes is called a simple event, but we can define other events. We can define an event A, which we can define as rolling a 1, 2, 3, or 4. And we can also define an event B, which would be, we can say, is rolling a 2, 4, or a 6. So in other words, A is going to be rolling something that is less than 5, and B could be thought of as rolling an even number. So we want to talk about how we can take events A and B and combine them to make new events. And the first word we're going to talk about is and. So in the English language, whenever we say and, we mean two things that happen at the same time. If you're saying, I want to eat a hot dog and a hamburger, right? You're going to eat both, right? If you just eat a hot dog, that statement's not true. And the same thing goes with combining events. If I wanted to define the event of A and B, then A and B are all of the outcomes that are in both A and B. So in this case, if we look at those two sets, the outcomes that are in both are 2 and 4. So A and B would be the outcomes 2 and 4. For or, we use or slightly differently in mathematics than we do in normal day-to-day English. Whenever we say or in day-to-day conversation, we mean one or the other, right? If you're invited to a fancy event and you're asked to pick what you want to eat at that event, and they ask, do you want the chicken or the fish, right? Customarily, you're supposed to choose one and not just say yes, right? But in mathematics, we're allowed to say both. So in mathematics, whenever we say or, we mean one, the other, or both. And so if we want to define a new event, A or B, then this is going to be all the outcomes that are in at least one of them, but also the ones that are in both. So in this case, 1 shows up in A, but not in B, but that's okay, so we include 1 here. 2 shows up in both, but that's allowed, so 2 goes in here as well. 3 is in A, but not in B, so it goes in here. 4 is in both, still okay. 5 is in neither of those, so we don't include that. And 6 is only in B, but that counts, and so this is A or B. And so A or B consists of the outcomes of 1, 2, 3, 4, and 6. Now, these curly braces that we're putting around these lists are because these are considered sets. And in any set, each element is listed only once, no matter how many times it shows up. So even though 2 and 4 show up in both of these, we still just list it once in here. So we never list anything in a set more than once, and no matter how many times it shows up in the sets that we're building in. So let's look at this another way. All right, so we talked about how to think about these and or terms to combine events as a list, as a set, but let's also think about how we can visualize this graphically. So you may be familiar with Venn diagrams. So if we have two sets, A and B, we can draw their Venn diagram like this. And things that appear only in A are going to be over here, and the things that appear only in B are going to be over here, and the things that are in both are going to be this middle. And so since I want to compare two different combinations, let me draw two Venn diagrams. So the outcomes that appear only in A are 1 and 3. So let's put 1 and 3 over here. The outcomes that appear only in B are just 6. So 6 is going to be over here. And the outcomes that appear in both are going to be 2 and 4. So let's put 2 and 4 in here. And I forgot to put 1 and 3 in here. So then let's talk about what it would look like to define A and B. So if we want to talk about A and B, then we're talking about the outcomes that are in both A and B. So on a Venn diagram, that would be this middle section. If we want to talk about A or B, right, that includes the things that are only in A. That would be this section here. It includes the things that are only in B, which would be this section here. But it also includes the things that are in both. So that would be this section here. So another way of thinking about these two ways of combining events is that A and B is the overlap, and A or B is the entire Venn diagram. The only thing not included in A or B is anything that doesn't show up in either of these.